Hello students, welcome to your chemistry class, and in today's class we will discuss general methods for preparation of alcohols and phenols. So our heading is preparation of alcohols. So at first we will discuss methods of preparation of alcohols. First, number one, from alkenes. That means we will prepare alcohols from alkenes. So to prepare alcohols from alkenes, the first method is by acid catalyzed hydration. Hydration means addition of water. Okay, so our heading is preparation of alcohols, and now we will prepare alcohols from alkenes. Therefore we have to take an alkene, and we are taking the simplest form of alkene, that is ethene. After that, the reaction is by acid catalyzed hydration. That means we have to add water, and the reaction is catalyzed by an acid, that is H positive ion. And in presence of acid, water will break and form H positive and OH negative. Water will break to form H positive and OH negative. Now one H positive will attach to one carbon, and the another OH negative will attach to another carbon, and the result is at first CH2 is present. After addition of this hydrogen we will get CH3. Okay, then this double bond will convert it into single bond and will form CH2, and due to addition of this OH negative we will get CH2OH. That means we will get ethanol. Okay, so by acid catalyzed hydration we can prepare alcohol. At first we have to take an alkene, okay, and to that alkene we have to add water in presence of an acid, and due to presence of the acid, water will break to form H positive and OH negative, and in one carbon H positive will attach, and to another carbon OH negative will attach, resulting formation of alcohol. Okay, let us consider another example. Suppose this one, CH3, CH, again CH2, okay, CH3, CH double bond, CH2. Again we have to take acidic water, acid catalyzed hydration. In this case again water will break to form H positive and OH negative, and now you have to remember this alkene will follow Markovnikov's rule, and according to Markovnikov's rule the positive part will attach to that carbon which have higher number of hydrogen atoms. That means this H positive ion will come here, and again OH negative will attach to this carbon. Hence the resultant alcohol is CH3CH. After attaching the OH negative we will get OH, then the double bond will convert it into single bond, and then we will get CH3. So this one is the resultant alcohol, and this alcohol is propane to all. Okay, so that means we have prepared propane 2-ol from propene. So in this case, you have to remember that when unsymmetrical alkenes are used, then those alkenes always follow Markovnikov's rule to give the alcohol. Okay, and according to Markovnikov's rule, the positive part will attach to that carbon which have higher number of hydrogen atoms. So we have get this product due to acid catalyzed hydration of propene. Okay, so first method is by acid catalyzed hydration, and we have already studied about it. Okay, very easy. Just remember that water will break to form H positive and OH negative ions, and the H positive will attach to one carbon of the double bond, and the OH negative will also attach to another carbon of the double bond. Okay, but in case of unsymmetrical alkenes, Markovnikov's rule is obeyed. Okay. So let us discuss mechanism of this reaction. Mechanism of this first reaction. So let us take a question. Suppose the question is, write the mechanism of the following reaction. CH2 double bond, CH2, H positive, H2O, and the product is CH3 single bond, CH2OH. So we have to write the mechanism of this reaction. Solution. This reaction will obey some steps. So in first step, the H positive will react with water to form hydronium ion, that is H3O positive, or O, H, H and H, one lone pair will present, and then this one. Okay, and the alkene will react with the hydronium ion to form a carbocation. So we have seen that one positive charge is present in this oxygen atom, and due to presence of positive charge, the electron of this bond will attract by this oxygen atom. Okay, resulting H positive ion, and this H positive ion will get the electrons of this pi bond, okay, to form CH2H single bond CH2 positive. Okay, that means in this case two double bonds are present. The two electrons of one bond is donated to this H positive ion, because the H positive ion is formed by due to attract of electron by this oxygen atom. Okay, so that means the bond will goes to this direction, and resulting CH2H CH2 positive, and water. Initially one lone pair was present. Now due to attraction of these two electrons, another lone pair will appear here. Okay, in second step, the resultant carbocation will attack the lone pair of water molecule. That means it will attract the lone pair of water molecule, resulting formation of CH3, CH2, okay, OH. Again in this direction another hydrogen will present, and due to attraction of electron by this carbocation, positive charge will appear on this oxygen atom, because at first this oxygen atom had 2 electrons, but now both these 2 electrons will donate to this vacant carbon, resulting positive charge on the oxygen. Okay, in next step, that is step 3, proton will lose. In step 3, proton will lose to form the alcohol. That means CH3, CH2, OH. At first one lone pair was present. Now due to attraction of electron by this oxygen towards itself, another lone pair will present, and one H positive ion will lose, and this H positive ion will attract by another water molecule, resulting H3O positive. That means hydronium ion. So this was the mechanism for this reaction. So you have to remember that water molecule will attach with the H positive ion to form hydronium ion. Okay, or this one is the hydronium ion. And again, since the hydronium ion has one positive charge on the oxygen, that means the oxygen is electron deficient, and due to presence of electron deficiency, this oxygen will attract the electron pair of this bond towards itself, resulting release of H positive ion, and that H positive ion get electrons from this pi bond, resulting CH2, that means CH2H. Okay, again, since in this bond 2 electrons are present and 1 electron is from this carbon and another electron is from this carbon, but since both the electrons are donated to H positive ion, resulting formation of this bond, therefore this carbon will not gain any electron, hence here one positive charge will appear and one carbocation will result, and we will observe the release of water molecule. Now this carbocation is very active and it will attract the lone pair of water, resulting a bond between the carbon and the oxygen, and due to formation of this bond, this oxygen will lose its electrons. Initially this oxygen has 6 valence electrons, that means 1 2 3 4 5 6. Okay, in these bonds 2 electrons are present, but 1 electron is from hydrogen, another electron is from oxygen. Therefore initially 1 2 3 4 5 6 electrons are present, but after donation of these 2 electrons in this oxygen, 1 2 3 4 5 valence electrons are present. Okay, hence here one positive charge will appear, which is known as formal charge. You have already studied in class 11 chemical bonding chapter. Okay, now since one positive charge appear on the oxygen, therefore this oxygen will attract the electron pair of this bond towards itself. Okay, and due to attraction of the electron towards itself, H positive ion will lose, and that H positive ion will attach with another water molecule, resulting H3O positive, okay, and the alcohol. So this is the mechanism for this reaction. So hence we have studied preparation of alcohol from alkene. The first method is by acid catalyzed hydration of alkene. So the next method is number B, by hydroboration oxidation. Okay, so in this method again alkene is used to prepare alcohol, and the alkene is used to react with diboron, that is B2H6 or BH32. Okay, you can take both the formula to represent the diboron. In presence of an alkaline solution of hydrogen peroxide and water. Okay, and in this case we will get alcohol, and due to presence of the peroxide the reaction will follow anti-Markovnikov rule. Okay, and according to anti-Markovnikov rule, when the water will break from H positive and OH negative, then the H positive will attach to that carbon which has lower number of hydrogen atoms. That means to this carbon H positive will come, resulting CH2, and the double bond will convert it into single bond and CH to OH. That means OH negative will attach to this carbon. So we have seen that in the earlier reaction Markovnikov rule was followed, and in this reaction due to presence of hydrogen peroxide anti-Markovnikov addition is followed. That means in earlier reaction we have converted propene into propane 2-ol, but in this case we have converted propene into propane 1-ol. So in exams questions are asked, how can you convert propene into propane 1-ol? Then you have to write this chemical reaction. Okay, again when in exam question will suppose asked, how can you convert propene into propane 2-ol, then you have to write the first reaction, that means acid catalyzed hydration. So we have studied preparation of alcohols from alkene, and we have get two methods. First one is by acid catalyzed hydration, and the second one is by hydroboration oxidation. Okay, now we will study preparation of alcohols from carbonyl compounds, that means from aldehydes and ketones. So our heading is number 2, from carbonyl compounds. Number 1 was from alkenes, now number 2 from carbonyl compounds. Okay, so here the number A is by reduction of aldehydes and ketones. Okay, so in organic chemistry generally we will use these reducing agents. Examples of reducing agents: number 1, hydrogen in presence of nickel, okay, or platinum or palladium. That means we will use hydrogen in presence of nickel or platinum or palladium. That means hydrogen in presence of nickel, hydrogen in presence of platinum, hydrogen in presence of palladium. Okay, and the next one is lithium aluminium hydride, and number 3 sodium borohydride, and both of them are strong reducing agent, strong reducing agents. And you always remember that in organic chemistry reduction means addition of hydrogen. In organic chemistry we will use the classical concept of oxidation and reduction means addition of hydrogens. Now we will convert aldehydes and ketones into alcohols by using these reducing agents. Okay, and you have know that in case of aldehydes and ketones, one carbon oxygen double bond is present. That means in case of aldehydes, RC double bond OH, this one is aldehyde, and the formula of ketone is RC double bond O R dash, this one is ketone. Now we will use hydrogen in presence of nickel, and we know that hydrogen in presence of nickel is a reducing agent, and reduction means addition of hydrogen. That means we will get RCH, one hydrogen atom will add to this carbon, that means CH, this double bond will convert it into single bond, and another hydrogen will add it to this oxygen atom, resulting CH single bond OH. Okay, or we will get RCH2OH, that means RCH2OH, primary alcohol. Again, when we will reduce ketone in presence of hydrogen and nickel, then one hydrogen will add to this carbon and another hydrogen will add to this carbon, resulting single bond between carbon and oxygen, and we will get RC R dash CH single bond OH, and this one is secondary alcohol. So always remember that when aldehydes are reduced, they will give primary alcohols, and when ketones are reduced, then they will give secondary alcohols. Find the products of the following reactions. Number 1, CH3 CHO, hydrogen in presence of nickel, or we can use lithium aluminium hydride. So we have get that lithium aluminium hydride, sodium borohydride, hydrogen in presence of nickel or platinum or palladium, they all are common reducing agents. That means in this case also reduction will occur, and we have to find the product. Again, suppose we have CH3C double bond O CH3, sodium borohydride, we have sodium borohydride, or you can use hydrogen in presence of nickel, hydrogen in presence of platinum, hydrogen in presence of palladium. Whatever reducing agent you want to use, you can use. Okay, now we have to find the product, and we know in this case CH3C double bond OH, we have this aldehyde, or we have break this aldehyde like this one. Okay, now we are using lithium aluminium hydride, And since lithium aluminum hydride is a reducing agent, therefore addition of hydrogen will occur to the carbon oxygen double bond, resulting this alcohol CH3C H again H, okay, single bond OH. That means we will gain CH3CH2OH, and in this case we will gain CH3CH single bond OH CH3. This one is propanon, and this one is propan2ol, okay, and this one is ethanol, and we have converted ethanol into ethanol. So in exams questions will also ask, how can you convert ethanol into ethanol? This one is aldehyde, therefore you have to put the suffix al. So we are converting ethanol into ethanol by reducing it with the help of lithium aluminum hydride. Again we are converting propanon, propanon into propan2ol by reducing it using the reducing agent sodium borohydride, or you can use lithium aluminum hydride, hydrogen in presence of nickel, whatever reducing agent you want to use, you can use, okay. So we have seen that when aldehydes are reduced, they will give primary alcohols, and when ketones are reduced, then they will give us secondary alcohols. So we are observing methods of preparation for alcohols. So first we have converted alkenes into alcohol by two methods. First method is by acid catalyzed hydration, and the second method is by hydroboration oxidation. Again we are converting carbonyl compounds into alcohols. So the first method is by reducing aldehydes and ketones. Okay, very easy reactions, and you can solve some problems or reactions by yourself. In your textbook many questions are given, find the following products, okay. In written form questions are also given, what will happen when this chemical react with this one, when ethanol will react with lithium aluminum hydride, okay, when propanon will react with sodium borohydride. So you can convert the reactions by yourself, okay. Now let us consider another method for preparation of alcohol, and the method is by reduction of carboxylic acids. Number 3, by reduction of carboxylic acids, and this one is the formula for carboxylic acid, okay. Now we will reduce carboxylic acid, and always remember that weak oxidizing agent will not reduce carboxylic acid. To reduce carboxylic acid we have to use strong reducing agent, and that reducing agent is lithium aluminum hydride, okay. And in second step we have to hydrolyze the product form, because in lithium aluminum hydride metals are present and active metal lithium is present, therefore salt will form, and we have to hydrolyze this salt, and hence in second step we have to use acid catalyzed water, that means acid hydrolysis, okay. And this lithium aluminum hydride will reduce the carbon oxygen double bond, resulting CH2OH. That means the carboxylic acid is converted into primary alcohol. So let us take example of this reaction, CH3 CH2 COOH, okay. Find the product of this reaction. Okay. So what is the product? Solution. We will break the carboxylic acid like this, okay, and then we will write the given reagents. And now we have seen that lithium aluminum hydride is very strong reducing agent, therefore it will reduce this carbonyl carbon, and we will get CH3, CH2, CH2OH. Okay, so we have converted carboxylic acid into primary alcohols. So next method is from Gigner reagent. Number 4, from Gigner reagent. From Gigner reagent. And the formula for Gigner reagent is RMgX. Okay. And always remember that aldehydes and ketones, this one is the general formula for carbonyl compound, that is aldehyde and ketones, react with Gigner reagent to give a salt. Okay. We have seen that, or we have already know that the electronegativity of oxygen is higher than carbon. Therefore, the electrons will attract by the oxygen towards itself, resulting partial negative charge. Okay, and in case of carbon, partial positive charge will appear. Okay. Now, this alkyl group is electron rich. Therefore, it will attract the positive center. That means it has higher electron density, and due to presence of higher electron density, it will attract the carbon because it has positive charge, and this carbon is known as nucleophilic center. Nucleophilic center. And since this R will attack on the carbon, therefore the electrons from this bond will go to this oxygen atom. Okay, and the result is O negative. That means this carbon will form a chemical bond with the R, that means alkyl group, and in this case only one carbon oxygen bond will present, and the oxygen will gain negative charge due to complete transfer of these pi electrons to the oxygen atom. And we have know that magnesium is metal. When this bond will break, magnesium will gain positive charge, and due to gaining of positive charge, magnesium will attach along with the halogen to the O negative ion. Okay, in next step, since salt is formed, therefore we have to hydrolyze the salt, and after hydrolysis we will gain the final alcohol. Okay, and water will break to form H positive and OH negative. This H positive will attach with the oxygen to form OH, and now magnesium positive and X will break down, and this OH negative will attach with this magnesium positive to form MgOH. Okay, so we have converted aldehydes or ketones to alcohol by using Gigner reagent. Now suppose we will consider this aldehyde HCHO, that means formaldehyde. The chemical name or common name of this aldehyde is formaldehyde, and the IUPAC name is methanol. We will convert methanol to alcohol. So in this case, 2 hydrogen atoms are present. So we have put the hydrogen atoms along with these bonds. Okay, suppose we are considering the Gigner reagent as CH3MgBr. Okay, this CH3 group will attach to this carbon, resulting CH3. Okay, here one hydrogen is present, and at this position another hydrogen is present. Okay, and we are using the halogen bromine. Okay, now after hydrolysis we will gain CH3 in place of R, and then H, or we will gain CH3 CH2 OH. Okay, so this one is ethanol. That means the formaldehyde give always primary alcohols. So when formaldehyde or methanol react with Gigner reagent followed by hydrolysis, then primary alcohols are formed. Okay, suppose we are considering CH3CHO, that means ethanol. The common name of this compound is acetaldehyde, and the IUPAC name is ethanol. So when we will use ethanol, then we have one CH3 group here. So due to presence of CH3 group, we have to write again CH3 group at this position also, and in place of hydrogen we have to add CH3, and the final product is CH3 CHOH CH3 or CH3 CHOH CH3. That means other aldehydes, ethanol, propanol, butanol, whatever aldehyde you want to take, you can take, and all the other aldehydes give secondary alcohols. This one is secondary alcohol. Okay, and if we take a ketone, suppose we are taking acetone, this one is acetone, or propanone. Okay, and we have to put CH3 group in this position, again CH3 group in this position. Okay, and we will gain a tertiary alcohol. Okay, CH3 CH3 CH3, all these CH3 are attached with this carbon atom to which the OH group is attached, and therefore this carbon is tertiary carbon, and the result is a tertiary alcohol. Okay, so you have to remember that formaldehyde give primary alcohol when formaldehyde react with Gigner reagent. All other aldehydes give secondary alcohols, and then all ketones give tertiary alcohols. So in exams questions are asked, write one method for the preparation of tertiary alcohol. Okay, so in this class we have studied about general methods for preparation of alcohols. So in our next class we will discuss chemical methods for preparation of phenol. So that's all for today's class. Thank you.